Oh, and we got Boston in the chat on YouTube. Like it. All right, I think we should be ready to get started. So with that, I'll give it over to Jay to kick us off here.
Sounds good. And Nir, do you want to go ahead and share your screen?
Yes.
And just a friendly reminder to, oh, nice, music's off.
Oh, perfect. That was automatic. Cool, guys. Well, everyone, excited to have you all today. Thanks again for taking the time to come out and join our live stream today. Today we're going to be talking about evals in OpenTelemetry. And in particular, we're going to be talking about how you, as someone that might be building a generative AI application, can use technologies like OpenTelemetry, like sort of monitoring tools, as well as some specific tools in that space to get more insight into the accuracy as well as the performance of your generative AI applications. In terms of what we'll be talking about kind of more prescriptively, the first thing is we're going to be talking about OpenLLMetry. Then we'll go into how to install OpenLLMetry in Node. And just as a quick overview there, like OpenLLMetry is basically sort of a sister project to OpenTelemetry that gives you more insight on that end. Then we're going to be talking about a sort of hobby application that Chris Griffin has worked on that instruments that application. And then we're going to finish off by talking about how you, as your app scales, can essentially monitor those scores and those metrics in production. But before we kind of jump into things, maybe we start with a quick round of intros, if that's okay. My name is Jay, and I lead the product team here at Highlight. For the most part, I'll be emceeing this, but actually, I think Nir and Chris will be taking most of the rest of this conversation. And so, yeah, with that, Chris, you want to do a quick intro on your end?
Sure. I'm Chris Griffin. I'm a developer advocate at GitKraken. And, I've kind of just started in this developer advocacy space. So I'm really stoked to just be participating with Highlight and getting some more practice under my belt. I've been an engineer for about 10 years. Before that, usually on the front end. And a fun fact about me is I used to get free gear as a snowboarder. Only free gear, never a paycheck, but it was still pretty cool.
And free Monster, right?
Rockstar.
Rockstar, free Rockstar energy.
Yep.
Nice, nice. Nir, you want to give a quick intro on your end?
Yeah, I'm Nir. I'm the CEO of TraceLoop and the co-creator of OpenLLMetry.
Awesome. Thanks, Nir. And lastly, Vadim.
Yeah, hey everyone, my name is Vadim. I lead the engineering team here at Highlight and excited to be sharing some more with you guys about OpenLLMetry as well.
Awesome, awesome. Cool. So with that, we will segue over to talking about OpenTelemetry and then talk a little bit about OpenLLMetry and how it's related. So with that, I will move the mic over to Nir.
All right, so hi everyone. I'm going to explain a bit about our open source project, OpenLLMetry. Yeah, as Jay said before, talking about OpenLLMetry, I think we need to talk about our ancestor, which is OpenTelemetry. And basically, when I'm saying ancestor, basically I mean OpenLLMetry is just an extension of OpenTelemetry and is fully compliant with the OpenTelemetry project. But I'm going to start with a quick overview of what OpenTelemetry is and why I think it's probably the most important project around the observability domain for the last couple of years. So OpenTelemetry is an open source project. It's one of the largest ones maintained currently by the CNCF, which is the Cloud Native Foundation. It's part of the Linux Foundation. And it's a standard protocol that's currently being supported by all the everyone, all the observability platforms that is out there, Highlight, Datadog, Dynatrace, New Relic, Honeycomb, Grafana, and many, many others. Probably if you're using any observability platform, it already supports the OpenTelemetry open protocol. But what is the OpenTelemetry protocol exactly? So it's a standard way for sending 3 different types of telemetries from your production applications, namely logs, metrics, and traces. So logs are the easiest ones. If you ever written some print or console log on your application, you've basically written a log. So OpenTelemetry defines a standard way of sending logs from your application into an observability platform. If we take it, to our LLM domain, then when you want to log and see the prompts and completions if you've gotten back from, let's say, OpenAI, then you want to use the logging API of OpenTelemetry to report that. Metrics is the second entity that you can send, second thing you can send on OpenTelemetry. And basically, metrics is any thing that you probably want to look at on an aggregate level. So let's say you want to see token usage, you want to look at latencies, you want to check out error rates. These are the things you probably would like to define metrics for, and then send them out, look at them on aggregates across days, look at the P90 values, et cetera, et cetera. And lastly, tracing. Tracing is your way of tracking multi-step processes. Whenever you have, you want to track a multi-step process, you want to see how much time each part of the process took, what's the relationship between these different sub-processes within the overall process. You want to look at traces. When we're in the LLM Gen AI domain, we are very interested in traces because they can help us understand these chains or workflows or RAG pipelines. Whenever we do something that has multi-step that each take a significant amount of time, we want to understand the overall process. So this is basically OpenTelemetry. The way it works behind the scene is that OpenTelemetry is a huge ecosystem, and for implementing this protocol that I've just described, OpenTelemetry built 11 different SDKs for 11 different languages. So we today have OpenTelemetry SDKs in Python and TypeScript, Go, and Java and Ruby, and tens, 6 or 7 different other languages. On top of these SDKs, we've built OpenTelemetry built something which is called instrumentations, which is, we're going to talk about it more in a bit, and collectors, which help us with the processing of the telemetry before we send them out to the observability platform. And again, I'm going to talk about it more in the next couple of slides. So instrumentations. So we mentioned logs, traces, and metrics. And while the OpenTelemetry SDKs provide a low-level API where you can actually manually log and report different metrics in your application, you usually don't want to do that because you use, some standard building blocks in your application. And basically, for every such building block, you probably have a standard set of metrics and logs you expect to see. So part of the OpenTelemetry ecosystems, we have these instrumentations that provide you with some out-of-the-box logs, metrics, and traces. You can easily view for that specific building block that you're using. So let's say you're using a PostgreSDB, then you want to look at CPU usage, you want to look at latency. So you just install the Postgres instrumentation, and you get all of these out of the box, just plug it into your observability platform, and you can see everything.
Cool. Nir, just to quickly interrupt, if you don't mind, I wanted to ask a poll to the audience about what folks use in their current OpenTelemetry stacks. So I'm going to try to do this and launch a quick poll. But the question is, what have you used OpenTelemetry for in the past? And it's kind of an input question if folks want to kind of share their thoughts. And if you haven't used anything, feel free to just say none, just so that we have an idea of.
Cool. You want me to continue in the meantime, or you want to wait for the answers?
Let's give it like a minute. if you don't mind. Does that work?
Sure. Yeah.
We already have 33% of people have participated. Give it another 30 seconds. Give it 15 seconds. Okay, awesome. And if we look at a quick review here, we have folks that say backend tracing and LLM tracing, and then we have Golang and GoRM. But cool, awesome. Nir, up back to you. Sorry about that.
Yeah, sure. Yeah, it's interesting to hear, what people are doing, are using OpenTelemetry today.
Yeah.
I think I've had a chance to talk to a lot of companies, in the past couple of years. I think it took a while, but I would say that right now it's basically a standard for most, enterprises, and a lot of startups are slowly adopting OpenTelemetry, sometimes even without even knowing about it, because they use tools that behind the scenes use OpenTelemetry. So it's great to see, and I'm a strong believer in open standards. So it's great to see that this catch, people are actually using it. Anyway, so we're talking about instrumentation. So instrumentations is your way of getting out of the box metrics, logs, and traces for the components that you use in your system. Everything is happening on the application side. So it's not like when you're installing this instrumentation, it basically hooks into incoming responses and outgoing requests. You don't need to do anything, and it has a really, really low footprint on your, on the application latency or performance. You shouldn't feel any different just by enabling an instrumentation. And lastly, around OpenTelemetry, I'm going to talk about collectors. An OpenTelemetry collector is basically a separate deployment. It's a container you can deploy in your cloud environment. It basically is composed out of few ready-made components that you can use to process those telemetries you send out from application before you send them out to the observability platform. So let's say you want to filter out certain data, you want to obscure PII, you want to sample and not send everything to that observability platform that costs really a lot of money, and you want to save some cost. So you can do that pretty easily with an OpenTelemetry collector, and you can also send it to multiple things. Let's say you want to use several different tools because each one has specific features for specific use cases, and you can do it again pretty easily with a collector. Everything is just a deployment with the YAML config. So each of these is just a matter of adding 2 lines into the YAML config, and that's it. You get many of these just out of the box. So it's pretty cool, and it's also part of the OpenTelemetry ecosystem. So we've talked a lot about OpenTelemetry. Let's talk a bit about OpenLLMetry. So we were using OpenTelemetry for a long time, and we loved it, and we're looking for ways to use it in the Gen AI domain, using for calls to OpenAI. But unfortunately, there was no way when we started this project. There was no way to get traces and metrics to when you use OpenAI, when you use Anthropic, when you use LangChain. So we built one. We built it. We called it OpenLLMetry, and basically it's a set of instrumentations we've built where we instrument different providers, so like OpenAI, Anthropic, Cohere, different vector databases like Pinecone and Chroma, different frameworks like LangChain, Llama Index, and Haystack. Right now, I think we already support more than 23 or 24 providers, which is really nice. And if you go to our open source, you just see, the list of each instrumentation is a separate package. So you can basically use it as if as you use any other, OpenTelemetry instrumentation. And we also built an SDK that makes it really easy to use it, because sometimes we've seen folks that kind of struggle with using the vanilla OpenTelemetry SDK. So we just created a nice wrapper around it, so you can use, all the instrumentations for Gen AI together with just a nice wrapper for OpenTelemetry. And this is basically what OpenLLMetry is.
Quick poll for the audience on what folks use to invoke their AI models. Do you guys use OpenAI, Anthropic, Cohere? And on the database end, what does your stack currently look like? Wait another 30 seconds. Awesome. We look at a quick poll on the answers. Looks like OpenAI, Mistral, I'm hearing, Pinecone. So a good mix of folks, seems like. And Nir, is Mistral supported by OpenLLMetry?
Yes, it's one of the recent additions to the open source.
Awesome. Cool. Back over to you. Sorry about the interruption.
Yeah. Cool. So I don't know if folks have any questions or anything you want to ask, but feel free to use the Q&A tool of Zoom if you have any questions. Yeah, and I'm going to proceed in the meantime, but feel free to ask your questions. So I think, we've talked a bit about OpenTelemetry and OpenLLMetry, and basically, if you think about them, these are tools that you want to use when you're building a Gen AI application and you want to move it into production, when you want to start monitoring at large scale how your application is performing. And many times people kind of confuse the difference between evaluation and monitoring. So I want to talk a bit about that. And basically, when folks say evaluation, they mean they want to evaluate different models, they want to evaluate different prompts, they want to evaluate the performance of their application under a certain set of conditions. But when they do that, they usually do it during development. So they run it on a batch set of some small set of examples. Because of that, they only run it a couple of times. They want to compare different models. So it's not really cost sensitive. You don't really, if you want to evaluate the performance or the quality that you get from a call to an LLM, from like the output you get from an LLM, you probably don't care how much will it cost you to run this evaluation, because you only do it for a couple of examples. Latency is also really not really important, because again, you do it on a low scale. You do it only a couple of times, and should be fairly straightforward. And lastly, many times when you want to evaluate your application offline during development, you have some ground truth. Let's say you build a RAG pipeline and you want to test it out on a couple of like toy examples, like toy questions. You probably know what you have, like some sense, or even have written down what is the expected answer you expect to get from that call to that RAG pipeline. So this makes evaluation a whole different task from monitoring, which is something you do in production when you have real users using your application. You have high throughput. You have probably hopefully you get millions of requests, millions of calls to OpenAI, which of course can also get pretty expensive. So if you want to evaluate the quality and you will look for errors or hallucinations in production, you must need some tool that will be, you know, you can really run it at almost zero cost, because you can pay a lot for every evaluation that you're going to run. Latency is super important for you when you're doing, real-time monitoring, because maybe, if you run something that detects low quality answers from OpenAI, you want to use that as a guardrail. You want to block certain responses from getting back to your users. So it has to be super fast. And of course, your actual users is using your product. So you have no idea what is the ground truth, what is the real answer, that is the right answer that the LLM should be returning. So monitoring is much harder and a completely different task than evaluation that you do during development. And I want to spend a couple of slides giving you, some ideas around what kind of metrics you can use that fall, that agree with these conditions, that can support high throughput, that cost almost zero to run, and can give you a lot of sense, give you a sense of how well your model is performing in production. So I'm going to start with the most trivial ones, which are basically just data that you can get from the metrics and traces that you have, for example, on OpenLLMetry. So you want to be looking at metrics like latency and cost and errors. The idea is that sometimes higher latencies can give you a sense of something has changed, something is not working as expected. Maybe if your entire application depends on the answer from OpenAI returning under a certain amount of seconds, and it takes much longer than something errors internally in your application. So this is definitely something I want to monitor. Also, I wanted to mention here is errors. So many people look for these standard errors that tools that frameworks providers like OpenAI return, but you'd be surprised at the amount and the diversity of different errors that you can get from OpenAI from a lot of really weird conditions. We had this customer, for example, that sent a couple of requests to OpenAI with similar looking prompts, and then started getting errors back from OpenAI just because OpenAI decided to block, really thought that they were trying to run some DDoS attack on OpenAI, so they just blocked all the requests for that customer. So you definitely want to look for the errors you're getting back from the providers and from vector databases, because they can give you a good sense of something is not working well in your system. And I want to give you two ideas, and this is not a talk about metrics. So there's tons of other metrics that we can also talk about, but we don't have time for it today. So I'm going to just give you an idea of two interesting metrics you can look for an easy way to look to understand the quality of and the performance of your application. And these are the Pinecone scores, or ChromaDB also returns some notion of a score, and the OpenAI log props. So let's start with the scores that every vector database is returning. I've taken Pinecone here as an example, but other vector DBs, if you're using them, also has similar notions of scores that they're returning in their responses. The idea is that when you have a RAG pipeline and you're getting back, you basically, let me quickly remind you, the user asks you a question, and you then go to a vector database to retrieve a context that can help the LLM then answer the user's question. So the context you get back from the vector database is a set of documents that you then pass as a context to OpenAI. And for each document, you get this nice score that is kind of, it basically gives you a sense of how far the query, the original question of the user, how far is the question in the embedding space from the document that you've gotten back. This means that if the document is really far away from the question, it's probably not relevant to the question. So it means that the user asks something that is completely irrelevant, which means the LLM is going to hallucinate because it has no idea how to answer the question given the context that you've given him. So, looking at scores and searching for if you look at a score, then low is worse than high. But if you get a distance back from a vector database, then again, it's the exact opposite. So high is bad and low is good. But looking at these scores and looking for anomalies can give you a good sense of when your model is going to hallucinate. And it's pretty cheap. You already get it back when you call the vector database. So you don't need to do anything. You just need to log it. And if you use something like OpenLLmetry, you already get it. And the second thing I want to talk about is OpenAI's log probes, which is another nice thing that OpenAI can return to you. You have to explicitly ask for it. So when you send a request to OpenAI, you have to explicitly turn on a flag asking for these log probes. But what you get back is a sense of how confident is the model with the answer that it returned to you. So again, this is a good way for you to understand how probable it is that the model is hallucinating. So it's not like, you shouldn't be looking at absolute numbers. Let's say below 0 point something is bad, but above is good. But you should look for trends and you should look for anomalies. If you get something which is out of band or out of the ordinary scores or log prob that you usually get, it probably means that there's a hallucination or there's a high probability for a hallucination. And again, it's just a question of, you just turn on a flag in the request you send to OpenAI and you get this data back. And this is another thing we log with OpenLLmetry. So you get it back and you can use it as a super easy, zero cost way of understanding if your model is hallucinating. Great.
Awesome. I'm just going to quickly ask one more poll because Nir, I know you love it when I ask polls in the middle of your presentations. And the question number one is, how do you evaluate your Gen A app right now? And that's just free form, just curious what people are using for evaluation right now. And the second is, assuming you have a Gen AI application in production, what metrics are you evaluating or observing in production? Latency, cost, response quality, response consistency, the log probs or pinecone scores that Nir just asked, or even things that are more complex like RAGAS. I'll give this like maybe a minute and a half since it's a good amount, but Nir, I'm curious on your end, like what's something surprising you find when it comes to monitoring? Like I know you work with a lot of customers that have like generative AI applications. Like what's something surprising you found that they encounter when it comes to monitoring for generative AI versus their more like traditional monitoring setup?
I'm always surprised at the anomalies and errors that we find. When you hit, we have customers sending us millions of traces. And
Sure.
at this scale, you can't really look at every generation and look for errors. So what they usually do is that they sample, they just randomly, manually look at some of the answers that they've gotten from OpenAI or whatever LLM model they're using, and look for errors. And so they catch some bugs and they catch some weirdness. And then, we run our own automatic evaluations and then we discover, these, okay, here are 2,000 different use cases we found of anomalies. And they were like, wow, I didn't know that this was an answer that the LLM returned for one of our users. So it's, the main problem with Gen AI is that it's really non-deterministic. You have no idea how will it actually react in production. That there's a high variance in the answers that you get back, no matter how you try to, cover all the cases in your prompt.
Makes sense. Yeah, it's really interesting. And do you think like sampling hurts that? Like when you sample in generative AI, just because there's so many anomalistic outcomes there?
If you want to monitor. So it really depends on what you want to find. If you want to look for errors, you want to actually find, those hallucinations and look at each one of them and understand why they're happening. And you can sample because you may miss them. But if you want to look at trends, let's say you have some metric and you want to see, let's say you switch from GPT to Anthropic. You want to see if something is better or worse. You can just sample the data, measure it with one of these metrics, and then look for, the trends. Look for the difference.
Makes sense. Makes sense. Interesting. Interesting. Cool. Well, on our poll, we have, I think, a good amount of answers. I'm going to quickly end it and just share some thoughts. Oh, wait, stop. I didn't mean to do that. Poll.
Looks like they should be sharing, right? People should be able to see the results right now.
Yeah. Oh, I see it now. Okay, awesome. So some of the answers in terms of evaluating your Gen AI app are RAGAS, custom LLM evals, getting experts to determine accuracy. So that's more so on definitely less of the sampling end that we just talked about with Near. Helicone, which I imagine is a product out there that lets you do that sort of thing. And then also like have multiple configurations. So maybe multiple options in terms of how they get that done. And then in terms of the metrics that people care about, response quality is the highest. Consistency and latency are second. And then it seems like cost, OpenAI log probs, and RAGAS are the third set of sort of cohorts there. So kind of really good insights for us, honestly, in terms of feedback on these sorts of things. But yeah.
I wonder, when folks say response quality, how do they actually do that? Because quality can mean
Yeah.
a lot of different
I guess
things.
that's like a version of the rest of the answers, right?
Yeah.
Good point. Good point. But anyway, yeah, thanks for answering, guys. And thanks, Nir, for giving us an overview of open telemetry as well as OpenLLMetry. And I do encourage people to check out TraceLoop. It's a really cool way to get a lot of this insight that we're talking about in your generative AI application. Now I'm going to move the mic over to Chris Griffin.
How's it going, everyone? We're just checking to see if I can get audio shared before I share my screen, and it doesn't seem like we can, so that's fine. We'll move on. I just have a demo of the thing I made, and it is audio based, so you're going to miss out on the demo of it, but I can at least describe it. All right, so you should all be able to see my screen, correct?
Yes.
Cool.
Yep.
So first, a little bit about me and my side project. I am Chris Griffin. I stream as CM Griffin on Twitch and YouTube and Algora, and pretty much just CM Griffin on all socials. That's just my handle at this point. I stream software development on my streams, and it's pretty fun. One of the things I do, like on Twitch, is you want to reward users when they subscribe or donate bits, or when you get rated, you want to do something fun and interactive for them. So I've created this thing called Twitch Voice Rewards, and this is basically the flow for it. So it listens for Twitch events from TMI.js, which is a JavaScript library, and it's just subscribing to the WebSocket connection to Twitch, and it allows me to listen for subscriptions, cheer, which is a donation, or raids. And I can basically then pass that username of the person that did that to an LLM with a specific prompt. Some of the prompts I have might be imagining them as a superhero or a supervillain or a sports star. And there's even a field for like a custom one, like if we want to imagine them as a cat or something like that. And then from there, I take that prompt response, the completion that we're given from OpenAI or Anthropic, and I pass it to a text-to-speech provider like DeepGram, PlayHT, 11 Labs. OpenAI also has their own voice provider at this point, but I wanted to mix it up with the providers just for testing. So getting that integration going was actually incredibly easy. So I have a back end that is kind of masking my API keys because you don't want to do that from the front end. And I am pretty much the only line that matters there is line 46 in my Hono code there. and it's just bringing in the traceloop SDK and initializing it. The base URL there and the app name are not as relevant because I'm going to be envisioning this data inside of Highlight rather than inside of Traceloop. And because Traceloop, the SDK for OpenLLMetry, is just binding to the OpenAI SDK or the Anthropic SDK via auto instrumentation, I'm not even needing Traceloop to send that data. The auto instrumentation is kicking into what Highlight is monitoring and sending to themselves anyway. So we're going to be able to get that data with basically no extra effort on my part. And I'd love to check out Traceloop a little more. It was just outside the scope of what I was doing for this right now. But one thing to remind you of is you have to use the SDKs. Doing so with just the REST API using a fetch request, it will get instrumented, but you're not going to get a lot of the extra stuff that you might get from Traceloop's OpenLLMetry SDK. Now, if we look at the data in Highlight, we can actually see the OpenAI.chat trace event is actually making it through, and we get all sorts of really cool data. We get to see what the completion text was. We get to see how many tokens were used, what model was used, and even the latency and timing of these things. So bare minimum, we need to record these things so we can actually investigate stuff later and see if maybe I could improve upon the results, if I could improve upon the output. One thing I've kind of noticed is that, how would I evaluate this later? I could definitely use an LLM to get info about the prompt results. I could also just use regular expressions. But the idea is maybe I take the completion and have it summarize it for me into a specific JSON format that I can then pass through as a log and query later in some way, or store it in a database, or all sorts of things. And why would that be useful? Well, when I do the sports prompt, right, imagining a user as a sports star, it's actually incredibly more common to get a basketball or a figure skating reference versus something more obscure. So being able to visualize and query for that data later, I could actually see that we're getting more basketball, so I could add something to the prompt to say, maybe try more obscure sports instead of common ones. And then maybe we get badminton or curling or something like that. Another thing would be measuring the metrics. So for what I'm doing, I'm not going to be doing any retrieval augmented generation. I'm actually encouraging hallucinations, etc. So I'm not caring about a ground truth for what I'm talking about, but still very relevant for what you might be doing with your apps. And, referencing back to what Nir was talking about, incredibly important depending on what your app is doing. But I may still want to visualize the latency between maybe OpenAI and Anthropic. I may want to visualize the amount of tokens being used for these things. And also just if it ends up giving me 2 minutes worth of audio, that's something I'm going to get billed for from DeepGram, when instead I might want to try and limit it to 30 seconds. So being able to track all of these metrics, store them, and then query them later to understand what's kind of happening at runtime so that you can fine tune it later is really what I would do to improve what I'm doing with this evaluation. So from here, I'm going to pass it over to Vadim, and Vadim knows a lot more about Highlight and how to query this data and understand it better. I am still figuring things out.
Awesome. Thanks, Chris. And I'll be showing a little bit about kind of what all this data can look like when you send it to a destination like Highlight. Obviously, as Nir mentioned too earlier in the presentation, there's a number of other options in terms of OpenTelemetry supporting vendors that can store that data and allow you to visualize it. Obviously, we're biased because we work on this product, but we work on a bunch of different features that make it easier for you to group this data and analyze it at scale as you have a lot more of these traces and various kinds of data coming in. So one way to look at each individual LLM call from OpenLLMetry is the individual span view. That allows you to look for every single span that gets emitted by OpenLLMetry. Now, as we talked about, OpenLLMetry
Vadim, real quick, do you want to share your screen?
Yes. Can you see my screen? Oh, it looks like we're sharing 2 screens. That's
okay. So that's fun. Let me just stop.
I think I just stopped yours.
Perfect.
Okay.
Thank you.
Yeah. I'm not sure. The new Zoom update, it makes it really confusing. But so what we have here is the ability to build a search for specific kinds of spans based on all that data that OpenLLMetry is capturing. So your code, maybe it's written in Node.js. I think in this case, Chris, your code is Node.js. So you're using OpenAI and Anthropic's Node.js libraries. And then when you install OpenLLMetry automatically wraps those calls to those downstream service providers and emits OpenTelemetry spans to a provider like Highlight. Those spans then capture a lot more structured information that we can take a look at to dig deeper into that data that's coming in. So for example, here, what we're showing is we see three completions for a soccer kind of match, and we can take a look at each of these spans individually to dig deeper at all the data that's being recorded. So we have the full prompt, the full model's response, and a lot more metadata that OpenLLMetry is collecting around the number of tokens, the potential cost depending on the type of model, etc. In Highlight, we have a high-level view where you can look at these different columns. You can add arbitrary columns based on all the OpenTelemetry spans that are coming in. And in this case, let's say we want to look at the ones, let's take a look at all of the chat completions and look at the ones that consume the most tokens. In terms of their cost, they're going to be the most expensive, let's say. So these are all of the requests where we had 99 tokens used in the response because it was a pretty large response body. We can also look at their duration and understand cost that way. But another way to look at all this data is to aggregate it up. So let's say we then want to take this and have a daily view of the cost of running our model every day and see how that's changing. Again, to detect anomalies, that kind of stuff. We can build a dashboard via the metrics product and build a chart that will sum up the daily number of tokens consumed so that you can compare that day to day. You can then break that down by the different kind of service provider, like Anthropic versus OpenAI. You can break it down by the types of models you're using, etc. So one way that you would then break it apart is you would take that query and take it over the last 7 days, but group it by the span name, for example. And that span name is going to be the provider name. So in this case, we see that in the last day, Chris switched from OpenAI to the Anthropic model, and now we have tokens going to Anthropic, but we can essentially compare that over time. So that's just kind of scratching the surface. Within the Highlight product, there's also the ability to look at logs out of OpenTelemetry. That's just more structured information coming from your backend, as well as capture exceptions and record sessions of what people are doing in your web app. So we can actually take a look at that voice bot that Chris built. What does the UI look like? What is each person doing in that UI? And stitch all that together. There's a lot more there that we've covered in other videos, and we're not going to go too far into that. But I think with that, I've covered kind of the key parts of Highlight where we can show all that different data that OpenLLMetry is sending over. And I just want to give a huge shout out to Nir for the entire OpenLLMetry project, as well as for taking the time to work on this presentation and sharing all this information with you guys. I definitely learned a lot about more of the evaluation for when you're actually developing a new Gen AI app, how to make sure that your model is performing, and then the difference between that and how you're looking at the performance of a model that's deployed to production. Obviously, that's going to be a little bit different, but yeah. So thank you again, Nir, for taking the time to go in depth there. We recommend everyone check out the OpenLLMetry docs if you want to get started, as well as to check out Traceloop for another way to send that data from OpenLLMetry. And with that, I'll open it up to questions from anyone else in the audience. I think we might not have anything else. Let me just check the YouTube stream. And I also want to thank Chris for working on this app, the voice bot. Unfortunately, we didn't get a demo of it, but it is actually really cool. Do check it. Is there a way that people can play with that themselves, Chris, or is that through your stream only?
So there's an older version of it that's available online right now, but it's currently just through my stream.
Gotcha.
Is that
so check out.
Yeah, Griffin, I was going to ask, is there a video? That video you mentioned, is that live or public or no?
I may have some clips. I think the VODs on YouTube should have some of that though. So that might be a way to check it out, but I don't have any good timestamps to recommend. So sorry about it.
No worries, no worries. We'll reach out to Chris after to see if there's anything you want to share, Chris, that we can share to the listeners after the fact.
Sounds good.
But
Cool.
yeah,
Any last
it is
questions
cool
here?
seeing all that, the models in detail when you actually have a live demo, seeing the voice get generated out of that other LLM call. One thing we didn't really cover on the highlight side, and with all that OpenLLMetry data, if you have a more complicated pipeline where you have a bunch of different steps in a sequence, you can visualize all of that. So perhaps that's food for another video that we do. Awesome. I don't think we have any other questions, so we can call it. I guess, yeah, just another big thank you to Chris and to Nir, and for the entire audience for joining today.
Thanks, everyone.
Thanks, guys.
Thank you.
Take care.